Hi guys, so now we are on number 6. So far in my previous videos, I already covered 5 different examples of simplifying trig identities. Now we are going to look at this number 6. I have one more to go. So guys, if you look at this number 6, this expression, now instead of working with one expression, we have two expressions. So again, we are not just going to start right away using any of the trig identities. Rather, we'll try to simplify this using the algebraic technique. So let us look at each of these pieces and then see what we can do here, guys. Please go back and if you think of these as two algebraic expressions, these are rational expressions. So if you have rational expressions like these, then I think the best way to actually simplify this is by creating a common denominator so that you can combine the two rational expressions and then try to simplify as much as you can. Okay, but before we do that, we also have to kind of recall the difference of squares formula, which is a square minus b square. So if you remember, a square minus b square, which is the difference of squares, equals to the product of a plus b times a minus b, right? So we're going to use that for the first term in the denominator, and then we'll take it from there. So I'm going to write this as 1 over sine theta minus cosine theta, okay? And then difference of squares, guys. This is like my a square minus b square. This is like my a square minus b square. And the other piece would be sine x plus cosine x. Okay, I simplified the denominator of the first expression. Then I have minus 2 times. I have cosine theta minus sine theta, but here I have sine theta minus cosine theta, right? So it seems like they're almost similar, and maybe we can do something to make them exactly similar to each other, so that they look exactly similar to each other, basically, right? So here, guys, if I take out a negative 1, indivisible 1, then see what is left. I'm left with sine theta minus cosine theta. Guys, let us verify that. Negative times sine theta is negative sine theta, and negative times negative is positive cosine theta. And the reason why we did this was because there is a sine theta minus cosine theta here, and I want to make this look exactly like that. The way to get it look like this expression is to take out the negative 1, take out the negative, and then what is left inside is sine theta minus cosine theta, which looks exactly like this piece right here. Okay, so guys, these are techniques, but these are not like any complicated techniques. These are basic mathematical techniques. Okay, so since they look now the same, then you also have to simplify the negative and negative. So it's like negative divided by negative. Negative times negative is positive. Negative divided by negative is also positive. So we don't have negatives anymore. These two negatives will finally end up being a positive. Okay, guys, we had a negative here, but when we take out a negative here, then that negative and that negative becomes a positive. Okay, guys, now look at these two rational functions carefully. This has a sine theta, this has a sine theta minus cosine theta, same thing here, but there's this missing piece that is not present here. So if in order to combine those two rational expressions, we have to have the same common denominator, right? So to get the same common denominator, we can multiply the second expression by, so let us make some room here. So let me put that plus here. So I can multiply this by sine theta plus cosine theta, right? So if I multiply this denominator by sine theta plus cosine theta, we also have to multiply the numerator by the same quantity, because we cannot change that quantity. We can only make the denominators look the same, but if we do that, we also have to multiply the same number, same quantity upstairs as well. So upstairs I have to also multiply sine theta plus cosine theta. Okay. So guys, it is still similar to simplifying an algebraic expression. We are trying to get a common denominator. Whenever you try to get a common denominator and you have to multiply one of the rational functions, the denominator of one of the rational functions by a certain expression or certain quantity, we also have to multiply the same thing to the numerator as well. That's all what we did. Now the denominators are the same. When the denominators are the same, we just write them out once, right? We don't write them twice, we just write them once. Guys, these two are the same, so we just wrote them once, and then now we are mathematically allowed to combine the numerators. You can only combine the numerators for a rational function when the denominators are exactly the same. We made the denominators the same, now we are going to combine the numerators. So let us combine the numerators. 1 plus 2 sine theta plus 2 cosine theta. So I already distributed this too. Okay. Let us see if we can go any further with this. Well, 1 plus 2 sine theta plus 2 cosine theta. There's nothing you can really do looking at the formulas here. But this guy you already know was sine square theta minus cosine square theta. So you can just basically kind of condense the denominator back into sine square theta minus cosine square theta. And we don't have any identity here which gives us what is sine square theta minus cosine square theta directly. Okay, so I think we can, it is safe to actually leave it like simplify it to this point and just leave it like this. Okay, so guys, this example actually had more steps than our previous examples, and there were some tricky pieces. Like you had to first get rid of this, you had to take out a negative, then negative becomes positive, and then you try to create the same denominator. While you do that, you have to multiply the numerator of the second rational expression by the same quantity, so that now you can combine the numerators, and finally this is the simplified form. Okay, so basically we didn't really use any of the identities, it was more about using the algebraic skills. Okay, so I'm going to stop here. In the next video I'm going to talk about the last example for the basic trig identities, and then we'll go into the sum and difference. Okay.